Okay, so let's take a look at a couple more chain rule examples that are really commonly pop up. All right, so sometimes when you have something in the denominator, this is a really common scenario. Um, it's just another way of saying it's to an exponent. And so same as if it was a single term, it's a really good idea to rewrite them as negative exponents. That way it's easier to see how to apply power rule. But if we're looking at this as a function in a function, notice this 3x minus 5 looks like it's plugged into something to the negative 2. So if we want to use chain rule to take the derivative of the outside is, what's the derivative of something to the negative 2 is negative 2 something to the negative 3. And sometimes I like to do it, leave this inside blank, because notice you're just focusing on the derivative of the outside. So kind of visually think about covering up 3x minus 5, like with your finger or something. So we just did the derivative of the outside times the derivative of the inside. The derivative of 3x minus 5 is what, just 3? This one's 3, negative 5 is 0. And so notice when we did derivative of the outside, it doesn't mean the inside isn't there. It's just that we weren't touching it for the purposes of the derivative. So this is derivative of the outside times derivative of the inside. And so we're all done, but we can clean it up a little bit. Like 3 times negative 2 is negative 6. And if we don't want to leave a negative exponent, just like we rewrote it earlier, negative exponent means the reciprocal. So this is 3x minus 5 to the third in the denominator. And so there we have the derivative of our original function. All right, let's look at another example. Let's say we have something inside of a trig function. So there, especially because of the parentheses or because it's literally inside the trig function, probably easier to visualize that that's the inside function. And so if we focus on derivative of the outside, so our outside function is sine, right? The thing that something else is plugged into. So derivative of sine is cosine. And then times the derivative of the inside function. Derivative of 5x to the third is 15x squared. And so we're all done. We got to fill our original inside back in, right? Because we don't touch that when we're doing derivative of the outside. So there's derivative of the outside times derivative of the inside. All right, let's try to combine two rules here. And this will go back to that advice I gave the other day about making sure that we're writing out steps. Because once we have all of these rules, the real power is in being able to combine them. All right, so if we take a step back and we look at this, notice, and sometimes it helps to put the dot in there just to emphasize it for yourself. We can see that there's product rule going on because we have a first thing that's multiplied and a second thing that's multiplied, so F and G. So it's a good idea to, somewhere separately, we're going to write down what F is, right, the first part of our multiplication for product rule. And we're going to write down what G is. The big use in this is not losing the forest for the trees. We can say, okay, we want the derivative of F and the derivative of G, so you can just focus on one thing at a time. Let's see how well I can zoom here. So we can literally focus on one thing at a time. All right, so notice taking the derivative of F is going to require chain rule, but thankfully it's maybe a quick, easy chain rule. Something to the fifth is the outside, and this is the inside. So the derivative of the outside, something to the fifth, is 5 something to the fourth. And then times the derivative of the inside is 2. Put our inside back in here, so we're all done. Although if there's some low-hanging fruit simplifying, something we can simplify real quick and easy, might be worthwhile to do it. So now we have f and the derivative of f. So we're just collecting up all the pieces that we need for product rule. So same thing, we're zoomed in here, we're only focusing on this, then we'll zoom out and look at the big picture. So derivative of this, derivative of the outside is 7 something to the 6th, right? Our outside function was something to the 7th. And then the derivative of our inside function is 3. And so I could simplify real quick with those outside numbers, coefficients, not leave them hanging. So I get 21 quantity 3x minus 2 to the 6th. All right, so now when I look at the big picture, back to what I was originally trying to do was product rule. Now I have all my pieces for product rule, right? I have first derivative of the second, so this one times this one. And then I have second derivative of the first, so this one times this one. Usually it's nice to do them in the same order so that you get used to what you're doing, but since it is addition, it doesn't matter, unlike quotient rule. So first derivative of the second is this times this. We can write them in any order, so maybe because it has a front coefficient, I'll put the green one first. So first derivative of the second, and then plus this one times this one. So 10, 2x plus 1 to the 4th times 3x minus 2 to the 7th. And like we said before, if the question's asking for the derivative, you don't have to spend a whole bunch of time after that simplifying. Just write down what the derivative is and you're done. All right, let's see if we could do one that uses quotient rule and chain rule. And there's definitely a couple questions on the derivative mastery test that use more than one rule. The biggest thing on those is just staying organized. All right, so first thing, like it says in the song, if you see a fraction, that might be a clue to take the derivative using the quotient rule. And it rhymes. So quotient rule is a little easier sometimes to recognize than product rule because it usually stands out. And there's an x right in here. So if it was just a constant, we could rewrite it. But we have variable up top, variable on the bottom. So we can write down this is like our high and this is our low. You could write them F and G and still call them high and low in your mind if you want to. Just for fun, because we're getting used to this, I'll still call them high and low. So our top term is just x, and our bottom term is this quantity 2x plus 3 to the 3rd. All right, one of these derivatives, easier to take than the other one. They're not too bad, either one of them, but derivative of 1x to the first is just 1. Right, bring down the 1, then it's to the 0 power, anything to the 0 power is 1. And then this one, notice, requires chain rule. So derivative of the outside is 3 something to the second, right? So this was something to the 3rd. Derivative is 3 something to the 2nd. We don't touch the inside. So there's derivative of the outside times derivative of the inside. Derivative of 2x plus 3 is 2. And so I'm essentially done, but I could maybe make it look a little bit nicer. All right, so then in comes the song. How do we remember which one goes first? So low D high minus high D low. So low D high is 1 times this. So obviously you don't have to write 1 times something if you don't want to. It's still hanging out there. So low D high minus high D low. So x times this term, which if I want it to look nice, I can put it as 6 times x, since it's going to end up out front anyways. And then over the denominator, square we go. And then notice if you square this denominator, it was already to the 3rd, it's going to make it to the 6th power. So you can do that in two separate steps, but just to save a little writing and fit it all on the screen here. And then once again, you don't have to waste a bunch of time doing a ton of simplification. We just want to know, and same thing on derivative mastery test, can you take the derivative? And so there's the derivative using quotient rule and chain rule at the same time.